All right, so far we've looked at how to write quadratic equations when you're given a vertex or the intercepts. Now what we're going to look at is how do you do it basically any other time. So when you just have three random points of data and you want to write an equation. Okay, I say 3 points of data because unless you have the vertex, you have to have 3 points to make a quadratic equation. Okay, just like how in a line you have to have 2 points to make a line, right? If all you have is 2 points, if you just have 1 point of data, that doesn't tell you anything about the graph, right? Because it could go however. If I tell you though that it's a line and you get 2 points, that's enough information. With just 1 point, my line could go who knows. But if I have 2 points and I tell you it's a line, then we're good to go. If I have 2 points and I tell you it's a quadratic, that's not enough information either. So if I give you 2 points and I tell you it's a quadratic, that doesn't tell you enough about what it looks like. Does your quadratic go like this? Does your quadratic go like this? Right? Does your quadratic go like this? I don't know. It's not enough information for me to go off of. Okay, so just like how for a line you need 2 points, for quadratic you need at least three. Once you have 3 points, that's enough to make a parabola with. Okay, so this one maybe looks something like that. Okay, now the exception to this is if you know the vertex. So if I tell you that this point is the vertex and then you have one other point, that's enough information because it basically does give us 2 points. Because remember, axis of symmetry, there's a third point over here. So specifically, if you know what points of the vertex, that gives you some extra know-how. So you have enough knowledge to build a parabola. But any other case, you need to have 3 points. Okay? So you have to have at least 3 points. Looking at this paper, this stuff up here, this is all just button pushing directions. So these are all the steps of what buttons you need to push on your calculator. So I'm going to start down here with our example, and we'll go through all those steps as we go through this example. Okay, so S. Bones is a doctor in deathly ill, a suburb of Chicago. One day, John Garfinkel comes in with a high fever. Dr. Bones takes a blood sample, finds that it contains 1,300 flu viruses per cubic millimeter, and that is increasing. So John is sick, and he's getting sicker. So John immediately gets a shot of penicillin, which is going to kill off the virus, right? The virus we're expecting to continue to increase for a while and then hopefully level off and go back down. Okay, so think about what's happening here, right? You got this medicine and the count is climbing in your blood. When they give you the medicine, you don't instantly get better. That's not how medicine works, right? It takes a while for the antibodies to build up in your body and fight the flu virus. So what you're going to see happen is you're going to see the increase. It'll still be increasing, but it's going to slow down. And then it's going to start slowly dropping. And then it'll start picking up speed as things get going. So that's the quadratic path that a flu virus is going to take. You increase. You get to a point where you start combating it, it slows down, and then it starts dropping. Okay, so that's what's kind of happening here. And then we have some data here about after 5 minutes, after another 5 minutes. So we're going to assume that this is a quadratic function, and we need to write the equation. So the first thing that I'm going to do is I'm going to set up basically a little table of values so that I have my points. Okay, where my x coordinate is going to be the time, and the y-coordinate will be the virus count. Okay, so I know that originally when he gets the shot, he's got 1,300 flu viruses, right? So at the time 0, he's got 1,300 viruses. Okay, then after 5 minutes, so at time 5 minutes, your count's at 1,875. And then after another 5 minutes, so now my time's up to 10 minutes, right? I'm at 2,400. Okay, so there's my little table of values. And in this table of values, again, we're defining that X is the time since the shot, right, in minutes. Okay, and then Y is the virus count. Make sure you define those variables. All right, so now from here, I'm going to graph this function. Now, this is where we're going to do all these calculator pressing steps. Okay, so we're going to take this data, we're going to enter this table of values into the calculator, and then we're going to tell the calculator to write the equation for us. Okay, so I'm going to start up here. So the first thing that we're going to do is we're going to go to our stat menu. It's this button right here. Hang on, can't see that. Here we go. So this button right here. So you got your stat button. You're going to go in there. Okay. You've got 3 different menus along the top. We're going to use the calc menu in a minute, but for right now, we just want this one. So I'm going to go into option 1, which is edit. Okay. It should say L1, L2, L3 across the top. If yours doesn't say that, then you're going to have to add one back in. It should by default say that, but double check that it does. If it doesn't, shoot me an email, let me know, and we'll get that straightened out. Okay. And this is where we're going to enter. L1 is going to be our X values. L2 is going to be our Y values. If there's data in your list, there might not be now, okay, but there may be at a time in the future. To clear all that out in one go, just move your cursor up to the title of the list and then push your clear button and then down. Okay, so I'm going to push the clear button and then the down button, and it zaps the whole thing. So notice it still says L1, but all those numbers are gone. Do not use the delete button. Okay, if you use the delete button, it's going to do something else. So just as an example, if I look on here, if I go up to the top, if I push clear and down, it's going to zap it for me. If you push delete, watch what happens. Everything goes away, but notice how now it says L2 instead of L1. Okay, L1 is still there and it still has those numbers in it. You've just basically hidden it. So you haven't cleared the list, you vanished it. Okay, so I'm going to add that back in. How you do that if you do end up zapping something out is use your insert feature. So I'm going to do second and then that delete button to insert. Okay, now you see this extra column show up, and then I want L1. That is down here above my 1 button. It's the same color as my second. So I'm going to do second and then 1. You'll see that it shows up as here as L1, and when I hit enter, look, there's those numbers back again. Okay, so when you're zapping your list, just use the clear button and then down. All right. Okay, great. So now we're going to enter these numbers from my table down here. Adjust this so I can see at the same time. So I'm going to type these in. It's going to go down by default, and I'm just going to hit enter between each number. So 0, enter, 5, enter, 10, enter. Then go to my next column, 1300, enter, 1875, 2400. Okay. Make sure when you get to the bottom that you should have the same number of numbers in each column. Okay. It's really easy on this one because there's only 3 numbers each. But if you have like a long list of data, it's really easy to forget one. And if they don't match up, then you're going to have an issue when you go on further. So just make sure you always have all the numbers. Okay, great. So we went to stat, we did edit, we cleared out the data, we entered our own data. Okay, and then here, there's supposed to be a line break here. This is supposed to be a new line starting there. So, oops. Okay, so from here, this is going to let you view your scatter plot. We're going to come back to this in just a minute because we're going to want to create a line of best fit. So we're going to skip this graphing part. This is how to get it so that you can see your scatter plot, and we'll come back to that in a minute. Okay, because we also want the function. So we're going to make a line of best fit. Okay, so what we're going to do next is go back to that stat menu. And now I want the calc menu here. So I'm going to go over to the calc menu. Okay, and here there's lots of different things. 1 variable and 2 variable stats. That gives you things like your mean, median, and mode. Okay, and then these are all going to be different types of lines of best fit. Okay, so a linear regression, that's like a linear line of best fit. You probably did that in Algebra 1. This is just a different type of line of best fit for a linear function. Don't worry about that. We're going to worry mostly about quadratic regression right now. So that's the one we want because we know it's quadratic. If you knew it was cubic or quartic, you would use those guys. Okay, there's a different kind of linear regression where they just make this other variable have the x. Okay, so I've never really used that. And ln regression, we're going to talk about ln's later. It's a natural log, exponential regression, a power regression, sine regression. So there's all sorts of different features here. For right now, we just want option 5, quadratic. So I'm going to go to quadratic regression. All right, and here's where this may look different depending on what kind of calculator you have. Okay, so if you have one of the older operating systems, yours is going to look like mine does right now. Okay, if you have one of the newer ones, then it's going to look something like this. Either way, perfectly fine. Oop, hang on. I hit the wrong one. There, it'll look something like that, okay? So either way is perfectly fine. It's just a little bit different of how you're going to enter it, okay? So if you have one of the newer OSs, then you're going to see it should say L1 and L2 by default. You want it to say that. Frequency list, you're just going to ignore, okay? So you're going to want to come down here to where it says store regression equation, move your cursor there, okay? And just pause for a second. This is where we're going to catch up. If you have this system, then you don't need to bother typing in anything except what we're going to put here for this store regression equation. Okay, so this we're going to do the same thing, and that we're going to have to tell it basically where do you want this equation to go. So I want to tell them calculate this equation, but I also want you to graph it. If we just wanted to calculate the equation, we could just go down to calculate or hit enter, and it would give me the equation. But I want to also graph it. So I'm going to go to the store regression equation. And then what we're going to do from here is you're going to go to the stat menu again. Ooh, no, I'm sorry. That was wrong. VARs menu over here. So see this button right here that says VARs? Over here it says VARs. So you're going to go to the VARs menu. My bad. Okay. And then you're going to go over to YVARs. So go over one to YVARs. You want option 1, which is function. So either hit enter or go down to 1, type that. Okay, and then these different ones, these correspond to when you go to your Y equals button. You know how it has the Y1, Y2, Y3 for different equations? That's what these are. So you're just telling it which equation do you want to have it plug in for in that Y equals. I'm going to put it in Y1, but if you were like, say you were doing 2 different regressions and you wanted to see both at the same time, you put 1 in Y1 and 1 in Y2. Okay, so I'm going to go ahead and tell it Y1, and this is what your screen should look like. So this guy, you've got the L1 and L2 there. The frequency list we're ignoring. Store regression equation Y1. Or if you have this operating system, put the Y1 at the end. Okay, and then just hit enter. So here I'm going to hit enter. Here, if you hit enter, it brings you down to calculate. You have to hit enter again. It thinks for a second, and then it's going to give you a screen that looks like this. Okay, now notice that these are very similar except for 2 things. One, I didn't actually change my data in this one. That's why the numbers are different. So hang on, I'm going to go back and do this again. So stat, edit, and see, these are the wrong numbers. I forgot to change them. So let me go ahead and change that really quick. Sorry, I'm doing this one on my phone because that's the only place I have the new operating system. So don't mind any notifications that pop up. There we go. Okay, so I screwed that up. No big deal. Now, what we can do, remember how if you hit enter, it redoes the last thing? So I just quit out to my regular screen and all that stuff is gone. But if I just hit enter again, it's going to rerun it for me. And then I got my new numbers. Cool, so now they match up. All right, so they match up. We're going to talk about this R squared thing in just a second. But what this gives us here is our equation. It gives you the generic form of the equation up the top. And then it tells you what A, B, and C are. So my equation, I'm going to rewrite this, but I'm going to plug in those numbers. Okay, so I'm going to set this aside for just a minute. Okay, so when I am writing my equation for part A, I can't really fit it in there. There's not enough space for me to write it. So I'm going to write it down here. But my equation is going to be y equals ax squared. A is -1. So -1x squared. Plus bx, b is 120, so plus 120x, and then plus c, so plus that 1300. Okay, and there is my equation for this data. Okay, so we've got our equation. Okay, now we want to graph this function. Okay, so from here, we are going to do the same thing on either calculator, so I'm just going to stick with this one for right now. Okay, so now we want to graph this. If you go into y equals, you're going to see there's my equation, right? That's the equation that we just wrote down right here, right? It automatically plugged that in for me. Now, it wouldn't have been a big deal for us to type this one because the numbers are really, really nice. But like if you have an equation where it's like decimals and gross stuff, you want to just have it plug it in for you because it's going to give you a more accurate equation. All right, so now this is where we're jumping back up to this part, okay? So we're coming back up here and we're gonna graph our scatter plot, okay? So first thing that we want to do, there's two different ways you can turn on a scatter plot. Okay. Way number one is see how above y equals, it says stat plot. We're going to go in there. So I'm going to do second, y equals. All these scatter plots are off. I want to go into the first one. I want to switch it on. So right now the off is darkened. I want to switch it to on. So I'm going to hit enter. There's different types of graphs that you can graph. We just want to scatter plot. So I'm sticking to that first one. The X list and Y list should by default say L1 and L2. Okay, if it doesn't, you want to change that. And then here you can change what your mark is going to look like when you graph this. I like leaving it on this shape just because it's a little easier to see than the dots. Okay. All right, so now we've got our scatter plot on, and you're going to notice if you go back to y equals, something's changed. See how that plot 1 is dark now? Well, the other way that you can turn scatter plots on and off is just by coming up here, move your cursor up to where that is, and hit enter. Now that, see how it's light again? That means I turn my scatter plot back off. If I go back into that stat plot, it's off. Okay, if I go into y equals, go up here and hit enter, I just turned it back on. So go back into stat plot, now it's on again. So that's the quick way to do it. As long as everything's set up nicely in your scatter plot, you can just flip it on and off like that. Okay. All right. So now we want to be able to take a look at what this graph looks like. So here's where we're going to go to our zoom option. And this is where down the bottom, there's an option zoom stat that is really helpful. So not zoom fit, zoom stat. We're going to go to option 9. I'm going to hit that. Okay, and now that can be really helpful because this gives us our 3 data points, and it'll always make sure that those 3 data points fit. But the problem is that I don't really see enough of the graph. I've got the upward swing of my parabola, but I'm missing a lot here. Okay, so that's kind of a good way to get started, but now I need to adjust my window manually. So I'm going to go into window. I'm looking at what they have. So my X values go from -1 to 11. So I want my X values to go a lot higher than that. I need my X axis to go bigger. So I'm going to say, let's go up to like 50 and see how that works. Okay, and then for my Y minimums, well, the minimum that they're at right now, ideally in my situation, the penicillin's going to take me down to 0, right? So I'm going to switch this to down to 0 because this is my virus count. Okay, and how much virus count do I want it to go up to? I couldn't see the maximum of my parabola, so I'm going to flip that to maybe 3,000, right? He was at 1,300 when he got the medicine, so I'm thinking 3,000 by the time the medicine starts to kick in. That seems likely. Let's see what that looks like. Okay, well, it's better. I can see more of the swing of the parabola, but my guesses were apparently terrible. I need to go up a lot higher, and I can't even see where this thing comes down, so apparently I have to go a lot wider too. So let's try, I'm going to increase this to 100, and let's make this, I don't know, how about 6,000? Let me try it and see what happens. All right, we're closer. I still can't see this x-intercept though, so go back and let's try making this 200. All right, here we go. So now I've got a decent graph. Okay, so I'm going to come down here, and anytime you use a graph, you always want to draw a picture of what it looks like. If you can hear a strange sound, that is my Watson. He is scritching up the rug to try to make it more comfortable to lie down on. Okay, and then of course I want to label my axes. This went up to 200. This went from 0 to 6,000. All right, so there's my graph. Cool. All right, now the question that they're asking us here is, does he need to go to the hospital if the count reaches, or he needs to go to the hospital if he gets up to 4,500. So is he going to need to go? So there's 2 different ways that you can answer this question. Way number 1, since we want to know, is he going to hit 4,500, is to do my vertex, right? Do second calc, and then I want the maximum, option 4. Notice that up at the top, by default, it goes to that equation. So I can calculate my vertex here, left bound, right bound, and a guess. So my vertex, my highest point is 60, 4,900. So if that's my highest point, does he have to go? Yeah, at some point he's reached 4,500 because his max is at 4,900, right? So yes, he will need to go to the hospital, and that's how I know. Okay, so in this case, I know because I can look at the vertex and see, okay, his vertex definitely, he's going up. After 60 minutes, an hour, he's going to be too high. So yeah, he'd have to go back to the hospital. All right, the other way that you could have done this is if you go back into y equals, right? We have this one equation. I don't want to change that because I want that equation to still be here. But we basically want to know, is the y coordinate ever going to be this 4,500? So I'm going to make a second equation where it's just y equals 4,500. So it's going to show me all the points with a y coordinate of 4,500. When I graph that, there's that second line. That's showing me where a y value of 4,500 is. And yep, does it cross? Yeah. So there is an intersection point between these two. So that tells me that at those 2 points, his virus count will be at 4,500. If the question had asked you when is he going to be at 4,500, this is how you'd approach it. You'd find that and then calculate the intersection. So second, calc intersection, option 5. All right. And if I was looking at him going to the hospital, he'd probably go to the hospital the first time it hits 4,500. So first curve, second curve, guess. So after 40 minutes, he's going to be at 4,500, and that's when he'll need the hospital care. Okay. Now, one other thing that I just want to show you when you use the trace feature. Okay. So if you use the trace feature and you're just looking for a particular number, when you push trace, you have to pay attention up top to what you're tracing. So right now, I am tracing the scatter plot. So you can kind of see my spider here. When I push the left button, my spider jumps between those 3 points, and then it refuses to go anywhere else because it ran out of points. If I push the right button, it jumps back between those points. Okay, it's doing that. It's a little tricky to see. Okay, so I can't trace along this graph because right now I'm tracing the scatter plot. If I want to trace along my graph, you have to use either the up or down buttons. If I push the up button, see how it changed up here? And now it says Y2. Now I'm tracing the Y2 equals 4,500. When I go left and right, I'm going to slide along that line. Okay. If I push the up button again, now I'm on Y1, which is my graph. And now when I go left and right, it's going to slide me along here. Okay. If I push the up button again, scatter plot, push it again, Y2, Y1, push the down button, it cycles you through them the same way, just in the opposite order. Okay, so that's just an important thing. When you have more than one thing that you're looking at and you want to trace it, use the trace button and then use the up and down arrows to flip between them. Okay, so that is your general idea of what we're doing here. Now there is one more thing that I want to talk about, and that is this R squared value. Okay, so when we went and did this part, right, see how it says R squared equals 1 at the bottom? Okay, what the R squared value is it tells you how well your data fits the curve that was generated, okay? So looking at your quadratic, you want something where your second differences are close but not exact, okay? So one thing that you might have learned at some point is that when you're talking about a linear equation, in a linear equation, so if we just make something really easy, like y equals 2x. So if x is 0, that's 0. If x is 1, that's 2. Okay, so this is a really easy linear equation. Okay, and anytime that you have an equation that is linear, you always know that your differences are the same. So if I look at the difference between these two numbers, I'm adding 2. From here to here, I'm adding 2. Here to here, I'm adding 2. Okay, so this right here, this is called your first difference. And anytime your first difference is the same, that's how you know you have a linear equation. When you look at a quadratic equation, okay, so we'll look at, again, just as an easy one, how about we'll do y equals 2x squared. Okay, so an easy quadratic equation, if I plug 0 in for x, that would just be 0. Plug in 1, I'm going to get 2. If I plug in 2, I'm going to get 8. If I plug in 3, I'm going to get 9 times 2 is 18. Right? So when I look at this guy, if I take a look at how these numbers are changing, well, this went up by 2. From here to here, this went up by 6. From here to here, that went up by 10. Those are not the same. So that tells me that it's not linear. But when I look at the differences between the differences, that goes up by 4, and so does that. Okay, so these guys are called your second difference. Okay, so the first difference versus the second difference, just how many times you checking. Okay, anytime that the second difference is the same, that tells you that you have something perfectly quadratic. Okay, now with a line of best fit, when you're fitting data, most of the time data will not fit. Like if you have real world data, it's not going to make a perfect parabola. Okay, so when we look at these, how do we figure out, is this parabola a good fit? Well, we take a look at what these second differences are. Okay, if they are perfectly the same, then we say that the r squared value is 1. Okay, so if the second differences are close together but not exact, that tells you that it's going to be mostly quadratic but not perfectly. Okay, and that's what this r squared value is. R squared value goes from, so 1 or -1 are going to be a perfect r squared value. Okay, so perfect 1 value tells you that it is a opening up parabola. That's exactly a parabola. And a -1 value tells you it's going to be upside down. That's not true. I'm going to have to go back and double check that. Yeah, I'm not sure about the -1. I'm sure about the 1. I'm sure about the 0, but I'm not sure about the -1. So let's ignore that for right now. Okay, so r squared value close to 1 tells you 1 is perfect. Okay, 0 is terrible. So if your r squared value is +1, that's great. If it's 0, that's terrible. Okay, so when we looked at this guy, this one told me that my r squared value is 1. It tells me it's perfectly quadratic, works exactly. They're not always going to. Okay, so you need to be able to see what your r squared value is so that you know whether or not you have a good fit. Now, your calculator by default doesn't tell you what the r squared value is, so you're going to have to tell it that you want it to. And this is something you're going to have to do once ever. As long as you never wipe your calculator, you will never have to do this again. Okay, so here's what you're going to do if you don't already have this. Your calculator already says r squared value on it. You're good to go. You can shut this video off. You don't have to worry about the rest of this. Okay, but if it doesn't have that r squared value listed, here's what you're going to do. Okay, so you're going to push the second button. Okay, and then you're going to go to 0. See how above the 0 button it says catalog? Okay, that basically just makes a list of everything that your calculator does. Okay, and then we want to go down. We're going to find something called diagnostic on. You could just keep pushing the down button until you get to the D's, but it's going to take a while. So what you can do, see it's got a little A button here? It's kind of like caps lock, except alpha lock. It means that when you push any of these buttons, it's going to go to the letter instead. I want to go down to the D's, and D is right here on this X to the -1 button. So I'm going to push that and see how it popped me down to the D's. Just a little shortcut. Okay, and then I'm going to scroll down until I find one that says diagnostic on. This guy right here. So diagnostic on. I'm going to hit enter. It shows up on my home screen. Hit enter again. It's going to say that it's done. And now when you run this, you should see that r squared value. Okay, so I'll show you one more time so you can see it on the phone one. So this one, I didn't have it. So I'm going to my catalog. So second and then 0 to go to my catalog. I want to go down to the D's. So I'm just going to put this X to the -1 button just to jump me down a little bit. Scroll down until I find diagnostic on. There it is. I'm going to hit enter. Hit enter again. It says done. Okay, and now when I go back and rerun that, so I'm going to use second enter. Remember, you can do that to scroll back through previous things you've done. There's my quadratic regression, and now you can see the r squared value at the bottom. Okay, so you do that once, you'll never have to do it again. You should be all set.